Now, in this question, we have sodium metal, and it's going to react with water to produce hydrogen gas and sodium hydroxide. And we have 0.05 moles of the sodium, and we're going to have 100 grams of the water. Now, the sodium and the water are going to make up a solution, and that solution is going to rise from 25 degrees Celsius to 46.23 degrees Celsius. And we have the specific heat of the solution. It's going to be 4.18 joules per gram per degree Celsius. And the question wants to know for the delta H value, or the change in enthalpy of the reaction. And so this question's got two different parts. First, it's got the reaction, and the other part, it's got the solution. So I want to have the solution here and the reaction here. And what you need to know is the solution right here, it gets hot, or at least it warms up from 25 degrees Celsius to 46.23. So this gets hot here, and the way this gets hot is the reaction has given energy in the form of heat to warm the solution up. So the flow of heat goes from the reaction to the solution. And so the amount of heat Q from the reaction is going to be equal to the amount of heat Q of the solution, except opposite in sign. So the reaction loses heat or releases heat, so that Q right here is going to be negative, and then this Q over here for the solution, it's going to absorb the amount of heat that's released from the reaction, so this Q over here is going to be a positive number. And what we need to know is, for this question, we're going to keep this Q of the reaction separate from Q of the solution. And so what we can do is calculate the amount of heat that's going to be released from the reaction using this delta H value right here that we're going to find. And so what I'm going to do is I'm going to put the reaction here, and in this reaction I'm going to have 0.05 moles of the Na, and then of the water I'm going to have 100 grams. So this one's moles and this one's grams. And because I have two different amounts of two different reactants, this is going to be a limiting reactant problem. Now, the limiting reactant for this problem is going to be the Na. This is the limiting reactant because it's going to produce the least amount of product. And if it produces the least amount of product, that's going to determine how much product we're going to make, and it's also going to determine how much heat is going to be released. So we're going to use this right here, the Na, as part of this reaction here to figure out how much heat is going to be released. And so we're going to do Q of the reaction is going to be equal to the delta H value times the N, or number of moles. Now we have Q of the reaction equals, we don't know what this value is here, so I'm going to put delta H here for unknown, and I'm going to do it per mole of the Na. And the Na from the reaction, there's a 2 right here, so I'm going to put a 2 moles of Na there. And so this right here comes right from the reaction here and here. And so this part in here, that comes from what we're given. And we're given 0.05 moles of this Na. So I'm going to put right here, I'm going to put 0.05 moles of Na. And so this is what we're given. This is from the reaction. If we do this number here, which is our unknown, and we divide that by 2 and then times this 0.05, what we're going to get is going to be 0.025 times delta H. And this is as far as we could go to figure out the amount of heat that's going to be released as part of this reaction in here. And so now what we can do is we can focus on the solution. So the solution I'm going to put right here. Now the solution is going to warm up. It goes from 25 degrees Celsius to 46.23 degrees Celsius. And so the warming and cooling equation looks like this. It's Q of the solution is going to be equal to the MC and then delta T. Now this C right here is going to be this 4.18 joules per gram per degree Celsius. Now keep in mind, when we have the specific heat, it's going to be of the solution. So that should be a big red flag that this M right here, this mass, is going to be the mass of the solution. And the solution is made up of both the sodium and of the water. And so what I'm going to do is do this. I'm going to say Q of the solution is equal to the mass of the Na. Now we don't have the mass in grams of Na, we have the moles of it. So let's go convert this right here to number of grams. And so I'm going to take the moles is equal to the grams over the molar mass. Now the moles is going to be 0.05, and that's going to be equal to the amount of grams divided by the molar mass of Na, which is going to be 23. And so when I solve this right here, I'm going to get the amount in grams is equal to 1.15. Now this is the number in grams I'm going to use as part of this equation right here. So I have 1.15 plus I have the mass of the water, which is 100. So I'm going to have 100 there. And then I'm going to do times C, which is going to be this right here. Now also notice this right here, that's going to be in joules. So my answer here will come out in joules. And so I'm going to have 4.18 there. Now I'll need the change in temperature. I'm going to do the final temperature is right here. It's going to be this 46.23 minus the initial temperature is 25. So I'm going to put a 25 down here. Now when I solve this right here for the Q of the solution, I'm going to get 8976.19. Now this is going to be in joules, so I'm going to put joules here. But if you look at our answer choices, they're all in kilojoules. So what I need to do is I need to convert this right here to kilojoules, because what I'm going to do is I'm going to take this number here and I'm going to put it in right here. And so I'm not going to use joules. I'm going to say, or I could have 8.976 kilojoules. So this is the Q that I want to use right here. And so what I'm going to do now is I'm going to do this equation right here, and this right here we already figured out is this right here. So I'm going to do this. I'm going to do 0.025 times this delta H value, and this negative here is going to be right there, and that's going to be equal to the Q of the solution, which is going to be this right here. It's going to be the 8.976, and when I solve this for delta H, I'm going to get negative 359, and that's going to be in kilojoules per mole. And so this right here is going to be the answer choice, and the answer choice that's going to be closest to that is going to be A.